Hey guys, I am here to help you out with some homework today. You'll see in your study guide that the next few lessons we have are a good bit of review and just some clarification about skills that are actually going to be super necessary for calculus. One of them is approximating the area underneath the curve, and we actually did a small lesson around this way back at the beginning of the year with the area underneath the curve for velocity versus time graphs, where we were looking at a highway, highway speeds, and we found out we could actually use geometry in order to figure out the area beneath, which actually told us the distance that was traveled. So I really liked this question. Stated, if y is equal to x over x plus 1, we have some function. We want to approximate the area under the curve between 0 and 4 using 8 left endpoint rectangles of equal width. So there's a lot to unpack here. I'm going to do it one step at a time, try to color code it so we can all be on the same page on how this function actually works out. So we know that this function is defined as y being equal to x over x plus 1. So what we want to do is figure out how to stick how to stick 8 rectangles underneath this curve. So the first thing we need to do is split up x, or 0 to 4 on our x-axis, into 8 equal spacings. So if we're doing 8 equal spacings, well, that's just going to be, and we need to figure out the interval, figure out the width of each rectangle. And so that's just taking our interval and dividing it by the number of boxes we want. So 0 to 4, 4 minus 0 divided by 8. We know that this is 4/8, or each one is going to have a width of about 0.5. So if we're looking over here, we're going to have one rectangle that has this width, and then another one that has this width, and then another half, then going to 2, 2.5, 3, 3.5, 4. We can check to see 1, 2, 3, 4, 5, 6, 7, 8 rectangles are going to be made. So this whole idea of this left endpoint rectangles idea is to kind of tell us what we're using for our height at every single point. So the way we're going to do that is by step 2. What we want to do is use y equals x over x plus 1 to find the height of our rectangles based off their left corner. So if I want to actually show this, well, first one isn't too obvious, but we're evaluating it at that left point. So the next one is going to be evaluated at this left point. And so this is going to be our function evaluated at x equals 1. So let's do that one first. F of 1 is going to equal 1 over 1 plus 1, or 1/2. So when x equals 1, y is equal to 1/2. So this is a height of 1/2. So we can keep doing this for each rectangle, knowing that we're using that height right here to really determine what the height of the overall rectangle is. We're doing this for each spacing. So notice how we're kind of undercounting a little bit with these little pieces. That's okay. And then we finally have this one right here. Awesome. So we're going to evaluate at x equals 1, x equals 2, x equals 3, x equals 4, x equals 5. So I've kind of already done this. You can check it out if you want, but our function at 1/2 is going to be 0.33. Our function at 1, or at 0, oh my gosh, this is 0.5. Apologies. So f of 0 is going to be 0. 0 over 0 plus 1 is 0. We have f of 1.5, which is going to give us 6, or 0.6. So that's talking about this height. So if this is 1, this is 1.5. This height right here is defining this whole rectangle. So then we have f of 2, which is going to give us 0.667. F of 2.5 is going to give us 0.714. And then f of 3, 0.75. Finally, f of 3.5. Notice how this one's evaluated at 3.5. We will get a value of 0.77. So we have all our heights. Now what we need to do is multiply each of these heights by the width. Okay? So step 3, multiply all heights by the standard width and add together. So we're going to have a very long string, but I think we'll be able to do it. So we have our total area is equal to f of 0, which is 0, times 0.5 plus 0.33 times 0.5 plus, now our height at 1, 0.5 times 0.5 plus 1.5, which is going to be our 0.6 times 0.5 for the width, plus 0.667, our height of our rectangle at 2, times the width of it, plus 0.714 times 0.5 plus 0.75 times 0.5 plus 0.77 times 0.5. So the whole idea behind this is that we were just breaking these up into even intervals, figuring out the height from the left value of each using our function. Notice how it intersects our function at every single point, every single left point of our rectangle. And finally, we do this really large, ugly arithmetic problem, which I haven't done yet. So we're going to see what happens when we do that. Plus f of 0.5 plus f of 2 f of 2.5 plus f of 3 plus f of 3.5. So we get about 4.34 when I'm looking at my calculator. So that number is great. It just means that we have 4.34 square units going on under here, but I really wanted to show you that process. We first had to check out how many rectangles we wanted underneath. Then we drew out our rectangles so that we could actually see what they look like so that we can find the height of each of them. And then we use the area for a rectangle, length times width, to know, hey, our length is standardized to half a unit and our width depends on our function at the left corner of it. We added them all up, we got 4.34. All right.